The purpose of our project is to learn the physics behind how to build a periscope. We will learn how to build a periscope as well as learn the angular trajectory of light reflected from the inside, coming from one side out the other. It will help us to work as a team to make sure that we complete our task and finish the project. And finally, it will help us to understand the significance of angles and how it is refracted and seen with the naked eye.
So for the data analysis, we got down the measurements of how we're supposed to use the light to get through one side and out the other. And at first, we didn't really know what angle we're supposed to have it at until we did some research on it. And we found out that it's supposed to be at a 45-degree angle. The mirrors are supposed to be at a 45-degree angle so that light can reflect off of it at a 90-degree angle. And so since the angle of reflection is equal to the angle of incidence, we use that information to reflect the incident ray through one side of the periscope to the first mirror, and from the first mirror to the second mirror. And since the first mirror and second mirror are adjacent to one another, that means that the first mirror is parallel to the second mirror. And so when it hit the second mirror, it bounced out, and then it bounced back to our eyes so that we can see through the periscope.
Okay, for the sources of error, for personal, okay, at first we measured the angles like a little bit too high, and then we didn't really calculate the 45-degree angles right. We like did 41, 42, 43.5. We didn't really get to 45, and then we ended up drawing it wrong too, so we had to like erase it and do it all over again. And we were just trying to get like a perfect 45-degree angle. And that took us a while to get because we don't really draw that good, except for Randall. He's the one that made it. But me and Cavell, nah, it didn't work out for us. And then for the systematic, the measurements, the triangle's wrong, like I said before. But the 45-degree angle, like we did like 46, 43.5, stuff like that. And then we glued it down in the wrong place as well, because it's supposed to be like further back, and we glued it up farther than it was supposed to be at. And then after we glued it down, we realized that the two mirrors were uneven with each other. So we had to like take it back off, like take both of the mirrors off, and do it all over again and make sure that they were parallel to each other. And then the mirrors would not stay up, so we had to put it down and hold it for a longer period of time so that the mirrors would not fall or anything like that. And then for the accidental and random sources of error, okay, so I got scared because I heard this random noise and I just put it down. I was like, I don't know why. I forgot what happened, but I got scared. And then so I kind of put it down slanted, and and yeah, so we went take it back up and like do it again. And then we glued it slanted as well because it's supposed to be even with each other, parallel. So we had to redo that one again. And then me, Cavell, and Randall, we had fun making this project. And then so we was all talking and we got distracted, and then the glue dried up, and we had to wait and like scrape the glue off and then do it again and not get distracted. So those were our sources of errors. Okay, so for the conclusion, first I want to start off by saying that me, Cavell, and Randall had a really fun time making this project, because at first we thought making a periscope would be easy. But once we learned the physics behind it and how hard we had to work to get the angles correct, we learned that it wasn't as easy as we thought. But back to the conclusion. Okay, so the light had to reflect properly so that we could see through the other side. And we used the law of reflection to, where the incident ray, the reflected ray, and the normal of the surface of the mirrors all lie in the same plane. And once we found that out, we found out that the incident ray and the reflected ray has to be angular to one another and also parallel to one another. And once we found that out, we knew that the mirrors have to be at a 45-degree angle so that it can hit one mirror and go to the other mirror and then go out, so then it can come back to our eyes so we can see through it. And I think we met our objective because we actually made a Periscope, which is like really exciting for us. And you liked it, our class liked it. I think we did a good job. And but we had a few sources of errors, but we corrected them. But overall, we learned that the trajectory of light is very, very important when you're dealing with a device that you're trying to see around something or when an obstacle is in your way. But I just want to say to you that thank you for everything that you have done for my class, and I wish you the best.